Compression test. Compressive testing shows how a material will react when it is being compressed. Compression testing is able to determine the material's behavior under crushing loads and to measure the plastic flow behavior and ductile fracture limits of a material. During a compression test, properties of the material including sample stress and strain are measured and various calculations made. Data is plotted as a stress-strain diagram. Data is used to determine qualities such as compressive strength, elastic limit, proportional limit, yield point, yield strength, and modulus of elasticity. With the understanding of these different parameters and the values associated with a specific material, it may be determined whether or not the material is suited for specific applications or if it will fail under the specific stresses. A compressive strength test measures the compressive load or stress that a material can resist before fracturing. The test sample form is usually a cube, prism, or cylinder that is compressed between compression plates. The force is measured by the load cell and data gathered by the test controller. In these applications, machine's platen-to-platen displacement is measured using the crosshead motion position encoder. Some materials fracture at their compressive strength limit, others deform irreversibly. So, a deformation limit may be considered as the limit for compressive load. With this introduction, let's get into the practical. The machine shown here is the UTM with compressive heads. By pressing the up or down button, the compression head can be moved either up or downwards. Once we set the machine, we will go for calibration. Once the calibration is over, we can place our sample in between the two heads, and by either pushing the up or down button, we can move the crosshead. So the crosshead should not touch the sample but just about to touch the sample. And then we will specify the test. So here is the test. My crosshead moving speed is 1.5 mm per minute as shown in the screen. Then go to test, select your test, and then go for browse. There you can browse your folder and create a new folder for your fresh specimen. And once you create your folder, then within the folder you can create a number of test data. So for our first test, I will create another folder. And after you created your folder, you have to enter the parameters, the width, the height, the thickness. So these parameters need to be entered in the... After you enter your parameters, go to method and then go to control and check whether all the data which you are given is correct. And when you click end of test, you can see three different things: sensitivity in percentage, value in kilonewton, the force value, and the maximum extension in millimeter. So usually we keep the sensitivity in 100% and the maximum force we can give what could be the maximum, so beyond that it won't go. Similarly for the extension also, for some samples we give 33% of the total sample length, for some sample we give 50% of the total sample span, depend on us. So beyond that it will not go. So here I will give 15 mm as the maximum compression since my sample length is around 30 mm. So beyond 15 mm it won't go, and with 15 mm it will stop testing. And then go back to test, and in test click next, which will show you the graph space, and then click balance load and reset gauge length, so which will bring these two things to 0. And after that click start. There you can see a message, auto balance is in progress, please wait, which means the crosshead which is just touching the sample will now touch the sample. Until there the auto balance is in progress message would be there, and after that the test will start. There you can see from this arrow mark, so the movement of the crosshead, it's actually 1.5 millimeter per minute. So in 1 minute it will move only 1.5 millimeters, so it's difficult to observe through the naked eye, but you can just observe the crosshead movement through this arrow mark. At the same time the graphs would be drawn until 15 millimeter compression. The test can either be stopped by ourselves manually or it can be stopped automatically after the threshold value is reached, the minimum threshold value. So the one which I gave is 15 millimeters, so I am going to stop it manually. So press stop and then go to return. So when I press return, the compression top head will retract back to its position. You can see, so I am going to press return and the crosshead is being retracted back to its original position. Okay, then when I see the graph, so I have all my graphs in this range, but only this graph which is somewhere here. So I don't want that graph, it could be because of a defective sample. So what I can do is I will go to the test number 7. So that's the test which is giving the 1500 Newton maximum compressive stress, while all the others are around 500. So I'll right click, delete specimen. So from there I can delete this defective specimen. Okay, so I'll press delete specimen. This will permanently delete specimen. Okay, so there you can see that results is removed and all the other 6 results are available right here. Alright, so once my test is done, I will go to finish. Click this button, finish sample, or if you want to continue you can press continue testing. I am done, so I am going to finish sample. So either you can give no if you don't want to do it, or if you can give yes if you have still samples. So I will give yes. So this is the output folder, HP user, here's my name, and this is the method of test. Okay, I will go to my file. So this is my test that I have done so far. So this is the PDF of the graphs. You can see the final graphs and the values in PDF form, and also in the Excel form also you can get the maximum compression. These values in the Excel form also you can get. And this one will give the individual samples data. So specimen raw data 1, if you open that one, so this is the data of that particular specimen, compression in millimeter, compressor load in Newton, and this data. So there are this many data, around 1200 data are there. From this data, if we want, we can draw Excel graph also, right? So each of this Excel sheet is for each particular sample. So here we have 6 samples. Here we can see we have 6 samples. So each particular samples Excel file is there, right? So I will close it and I will export this one to my pen drive. Okay, that's it.